Well, hello, and welcome to the Pioneers Show, the show where we talk with innovators, makers, entrepreneurs, basically people who are trailing their own trails and creating their own lives, so that we all can learn how to work on our own lives. This is episode 3, and I'm your host, André de Albuquerque. You can find me at It's the Andre on Twitter and on Instagram, as well as the show at Pioneers Show on Instagram as well. With us today, we have Sam Williams, a hell of a smart person. I had a chance to meet him while I was working at Techstars Berlin. In this conversation, we go through Sam's experience developing and creating the Arweave project. But the real gem of the episode is actually when we focus on an area that I was not expecting at all to go: authoritarian regimes and how information spreads or in some cases can be stopped. We also discuss a little bit about quantum computing. I know, a lot of different areas. As much as I would love to keep talking about this, it's better for us to jump into the conversation with my man, Sam. So, and here with us we have Sam Williams. How are you, man?
Good, thanks. How are you?
All good, all good. Thank you so much for taking the invitation. I know this is a very stressful week. I know it just said that pre-interview. I know it's a great pleasure to have you here on the Pioneers Show.
No, it's great. Glad to be here.
So, for the people at home that don't know who you are, care to give us a presentation about you?
Sure. I'm the co-founder of the Arweave project, which is an attempt to build a permanent information storage system on a new kind of blockchain that we call a block weave, that basically you can shard across many computers, the storage of it.
Okay, that was a weird amount of names and words that some people at home might not understand. So we already had one person in the show to talk a little bit about blockchain. So can you elaborate a little bit what's blockchain, just in case some people at home might have not understood that, and what's the difference between blockchain and block weave?
Sure. So a blockchain is a system of decentralized consensus about data in a network. Typically it's financial transactions and who owns what, registries of who owns what. But in our system, we've expanded it in the block weave so that it can take very, very large amounts of data. So everyone can come to consensus about, say, the contents of a video file or something like this. You can zoom out a bit because actually you don't need to know what it is to understand what it offers you. Okay, so what does it offer? Permanent information storage.
Okay, permanent information storage. Are we talking about articles? Are we talking about a book? Or what are we talking? Just normal data, from financial data to whatever.
Yeah, I mean, it's a platform. The best way to think about it is a global permanent hard drive. So something that you can write data onto and you can read data off forever.
Okay, but the word permanent here, it's a little bit tricky.
Sure.
Okay, everybody says that once on the internet, always on the internet.
That's a really interesting one. This is a common misconception, I think.
Okay.
It's actually more the inverse, or not quite the inverse, is that it's incomplete. It's that once it's on the internet, you can't be sure that it's never deleted, that it's all. However, once it's on the internet, that does not mean that it's always going to be available. Actually, a huge amount of things get lost on the internet. For example, I think it was a Nobel laureate's from, was it 1963, perhaps, writings that they won a Nobel Prize for. Nobody has a copy.
Nobody.
Now it's only 1960s. It's crazy.
So there's a huge misconception about the once on the internet, always on the internet. But you provide a service, I assume, or a project that provides permanent storage. What's the cost first?
The cost is, so you pay once to get the data into the system, and then the replication of that data becomes part of it's the proof of work of the system, which in Bitcoin is typically hashing. So what's interesting about that is that basically in order to generate tokens in these kinds of systems, you want there to be some value, essentially value conversion. So in Bitcoin, you guess a whole bunch of random numbers to generate these tokens. And in doing so, there's some difficulty. Some work has to go into the generation of the tokens.
Okay.
So they have some kind of held worth, right?
Okay. The work that you're saying, it's the expenditure of energy that everybody talks about every day, that a Bitcoin can be at $4,000 in energy expenditure alone, right? Is that the difficulty?
It's how the system is, at a basic level, it's actually simply how the system is secured. So you have a very large number. In fact, it's even more basic than that. That electricity expenditure in Bitcoin is simply so that the timestamp in the system continues to progress at a constant rate, no matter how many people are in the network doing things. But the basic difference with our system is that once you put data into the network, less electricity expenditure has to happen, but members of the network are financially incentivized to store the data.
Okay. Going again to the permanent area, because that seems a little bit... Okay, if we talk about books, maybe that might be interesting in articles, but who wants their personal data definitely permanent?
It's not for every kind of thing, that's for sure.
Okay, so what kind of data do you see getting stored on the Arweave?
Yeah, there are two sides to this. The reason we got into it in the first place was because we wanted to make the idea of book burning impossible.
Book burning?
Yeah.
Okay.
The idea that an authoritarian regime or government can simply remove information from the consciousness of humankind as a collective. So we made a system of indelible ink, essentially, where you can put news articles, say, that can't be censored after the fact, and other such things. So it's scientific journals, this sort of thing. But on the flip side, you can also use it for a whole bunch of commercial purposes, like contract storage. So if we make a contract between us, we want to make sure that we can access it later, it hasn't been lost, and also that we can verify that its contents haven't been changed. You put an encrypted copy of that onto the Arweave, and it's there forever. We can refer back to it.
And I think that if you do, at least I see that there might be some big value in terms of contracts and probably other kind of legal documents for regulatory reasons, right? I remember you talking with me and telling me that the contracts in some kind of insurance need to be insured or stored for up to 50 years.
Yeah, completely. So
that person might die in his or her contract, might still have to be available.
So this particular thing is employers' liability insurance in the UK. It was just one particular example that we personally came across, where if we don't store that data for, I think it was 40 years, it might be 50 years, I can't remember. Either, it doesn't really make a difference.
It's huge.
Yeah, right. Sorry. Yeah, if that data is not stored for that time, then the company involved can be fined a very large amount of money. I believe it's in the realm of £20,000.
Okay.
And also to arrange storage of data for 40 or 50 years is just an absurd task for an individual or even a small organization to attempt to achieve. It simply won't work. Because even if you store that data with Amazon, right? Amazon's a pretty long running service. But in 40 or 50 years, what's the likelihood that they'll have changed the offerings that they have to you? It can't be less than 95%.
Yeah, of course. Okay, going back to how did you get into Arweave? So you said that you wanted to eliminate censorship by governments and bigger corporations. You wanted to eliminate the book burning idea.
Political censorship.
Political censorship, sorry, of course. But how did you actually get into Arweave? So you were sitting around reading a book and then wanted to read more and knew that book was burned and then decided to build it. How did you get into distributed systems? How did you get into the Arweave? Let's put it that way.
So there's two strands. I've been watching blockchain develop since 2010, since before Bitcoin got parity with the dollar, which I remember seeing and thinking that was completely crazy. Like, how can this, fancy internet money be worth more than the US dollar? I wish I'd bought. And then, at various other points since then, I got into blockchain for a while. So around, I think it was 2013, when the altcoin market first took off. Altcoin, yeah, it means alternative.
Altcoin, sorry. So the Ethereums, the Ripples, the Moneros of this.
Yeah, but at the time it was really what we term nowadays shit coins. And those that hold no real value, no use, and they're just spin-offs of like Bitcoin. So the first major altcoin was Litecoin. And that was fairly interesting. And the argument at the time was, well, this is silver to Bitcoin's gold, right?
Okay.
Okay, sure. And it kind of has some interesting potential validity to the argument because the systems are secured by hashing algorithms, and Bitcoin uses
hashing being a kind of cryptographic equation.
Yeah, all it really means is I put a number in one side and I get a completely random number out the other side. But if I put that same number in again, I'll get that same random number. So if that, and crucially, like if the number I put in is 1, I'll get 10 million or something.
Okay.
And if I put 2 in, I might get 5 billion or something. There's no real relation between or it's not like it's linear.
It's a cryptographic relationship, not necessarily a linear relationship.
The important thing is that you put a number in one side and you can't, it's deterministic. You'll get the same number on the other side.
Okay. So you were saying, Litecoin, silver to Bitcoin gold.
So Bitcoin uses SHA-256 as its hashing algorithm.
Okay.
And Litecoin used Script, which was this other hashing algorithm. Basic same property. But what's kind of interesting is that actually, like, if there was ever a break in SHA-256, then who knows what would happen to the Bitcoin price? And certainly not good things. And so having this sort of alternative currency that uses a different hashing algorithm that might not be susceptible to, wouldn't be susceptible to the same break, does make some kind of sense. But anyway, those weren't the kinds of things we were looking at the time. The real, I mean, the ultimate of the shitcoins, I think, would have been from 2013 was this thing called University of Texas coin. And this was when everyone and their dog was rolling their own cryptocurrency. And this guy from University of Texas, I'm sure he's doing well now. I'm sure he's improved in skill substantially. He took the Bitcoin code base and he replaced the Bitcoin logo with the University of Texas logo. And and then he released it on the Bitcoin Talk forums altcoin subforum and said, hey guys, I started a currency for use on the University of Texas campus. And it made no sense. But to my surprise, there were actually people replying and like trying to mine this thing. They're expending value, getting these crazy worthless tokens. And then the guy that made the system comes along on multiple occasions and is like, oh, I don't know how to get the IP address so that you guys can join my network. And it reached peak ridiculousness when the guy that started his own cryptocurrency comes back and says, hey guys, I've got this error. Should I reboot my computer? And it's like, oh God. Yeah. Anyway, so that was pretty interesting. Like that I thought was peak ridiculous.
But you are already deep down doing blockchain studying and learning more about this wonderful new technology that some people never heard of.
Yeah, I guess. I mean, at the time, it's just browsing around the internet. It's just kind of interesting. I wouldn't say I ever like focused on it too much. But I did mine some Bitcoin on my GPU in my shared university accommodation, so I didn't pay for the electricity.
Nice.
Yeah. I got about £15 worth and I traded it to about £30 worth, which was just nothing. And then I bought the Ethereum pre-sale for 17 pence. So that was a good return. You know?
Interesting. And so one question when you're talking about cryptography, so one of the main things that I've been reading lately about blockchain, I mean, it's a very futuristic view, but what's your view on the possibility of quantum computing becoming standard with cryptography today?
It's interesting. I think that would cause some problems, but we'd recover fairly quickly.
We as in Arweave or we as in blockchain community?
The wider security community.
Wider security.
Yeah.
When you say security, just so I understand.
I mean computer security.
Okay, so okay.
The cryptographic community.
Okay, just to clarify. So when now that you've been building, when did Blockweave start?
Right. This goes back to, so there was that thread and I was kind of interested in blockchain. That's all right. But I kind of faded in and out of it, you know, after the University of Texas coin shenanigans. Would you know it? The market crashed unbelievably. It was like, oh, okay. But then we saw it build back again. And that was the third time I'd seen it by that point, which I thought was interesting. Then, back in 2017, I was reading the Gulag Archipelago by Alexander Solzhenitsyn, which was a book about the Soviet work camp system.
Gulag Archipelago.
Yes.
Okay, we'll link that in the show notes just so if anyone wants to read it.
Yeah, it's a pretty harrowing affair. It's probably one of you can't get through that book without it changing your life. That's for
really
sure. Absolutely. Like,
what is it? What it is about?
It's a description of the atrocities of the Soviet, really the Soviet system in general, but focusing particularly on the gulags, which are these kind of concentration camps, essentially. And how
during the Siberian and the Soviet empire and
in the Kazakh desert and all sorts of places. But it focused on how these systems instilled themselves, like how the whole thing developed. How did we get to this point? That's perhaps the central question of the book. So I was reading this and I was thinking pretty deeply about how authoritarianism builds. And it struck me that one of the things that is necessary for these systems to instill themselves is information control.
So information control leads, when you say information control might not necessarily mean censorship, but the fact that you can control information, the information that comes out can lead to authoritarian. I don't know how do you say the word?
Authoritarianism.
Authoritarianism. Okay.
Yeah, so censorship is one part of it, right? That's the stopping of this. I think the best way to think about this problem is to notice that society is just a decentralized system of actors, where the spread of knowledge is the links you get in the network, right? So I'm having a conversation with you, and I'm sharing ideas, essentially. And then maybe there are some people listening, and those people hear the ideas
and share the information themselves.
Right, precisely. And if you notice, what's happening is really the ideas are just spreading around society. But what's cool is that each person that listens to that idea is like, okay, maybe this bit's interesting, that bit's terrible, ignore that, but then modify the good part of the idea, and they spread that modified good idea to other people. And societies work like this to collectively come to good ideas.
Okay.
You actually see the same thing in the startup world, right? The whole idea is that you do 100,000 things, 99% of them are dumb and end up just not working. But the 1% of ideas that are good
spread like wildfire.
They spread like wildfire. And then the next set of good ideas are based upon them again. And you recurse over and over again until you end up with better and better ideas.
So
theoretically.
So in theory, just to understand. So basically, you have a shit ton of bad ideas, but then you have that one big idea, and then every good idea that will come up is thanks to that main first idea, or is it an outcome, or just to understand the theory? Sorry.
It's pretty similar to what we call in computer science generate and test as a strategy. So you generate a whole bunch of random possibilities, and then you test all of them, and then you rank them. And then you take the top ones, and then you generate more mutations on those ones.
Iterations and everything.
Over and over again. But the broader point I was trying to make is if you look at society, it's basically like we're all doing this. And what we've done with democratic systems are just an expression of that in the sort of high extent. It's the acceptance that none of us know good answers, right? We don't give a single central authority the power to run society for long periods of time because we acknowledge that the people just don't come up with all the good ideas on their own. Right? There is no matter how smart you are, you're mostly wrong about everything. Well, like shades of gray, but it's better if we get the crowd to come to a decentralized consensus about what should be done in general. So anyway, thinking about authoritarian societies, what the regimes do is they stop the spread of information. That's the censorship part. And they also spread other ideas that are not selected by the crowd so much, but enforced from above, which is, in collection, I would call information control.
Is there anything like that in today's age that you see?
In our age?
Yes.
In the West, or?
Let's put in the West first.
Well, I mean, you could argue that what's happening with the media is kind of interesting in this way, because what used to be was that a few central media organizations would collate the good ideas from society theoretically and then redistribute them to the rest of society, right? But what you see now with social media more and more is that the group of people that are having their ideas, their good ideas, exposed to wider groups is becoming larger. It's becoming more decentralized, you might argue. While the platforms themselves that they're spreading the ideas on are still centralized. Today, you get your news from this guy, and tomorrow you might get it from another guy, and the next day another guy after that. But before, you might just have read one news source over and over again, repeatedly. So that's kind of interesting, but it's not really the same thing. Well, no, there's shades of gray, isn't it?
Yeah. You already said that there's some shades of gray there. So, but going back to our weave here in terms of permanent information, at the same time getting a distributed idea, so a very open way of getting things to stay forever. Isn't there a tremendous risk in today's age of the fake news information? So if so many people, and if there's so much ad spend in the fake news spreading of fake news information, how relevant do you think that getting that information as fake to stay on forever? Because, I mean, we are here now and we can contest that information, even though it's already in the network and in that block weave forever. In 50 years from now, no one will be able to know right away if this is fake or not.
Actually, right? I think it's the reverse. I think it's harder today to work out whether something's fake than in 50 years' time. You know, looking back on things makes it generally easier to know what was wrong. But the basic principle as regards mis or disinformation and the Arweave is that we take a somewhat pessimistic view in that we don't think that you can programmatically decide what is true, because that is almost the point of this decentralized network in society of humans. Like, the whole idea of that network of humans is to decide what is true, and we do an okay job at it. But it's unbelievably complex. The idea that you're going to be able to write a computer program that can find the truth for you, and if you give it a few paragraphs and say, this is true, this is not true, is, to me,
it's ridiculous.
It just doesn't seem like it's going to work. It actually concerns me pretty deeply that we'll try, because, it's just going to cause centralization, potentially centralization in computer systems that no human understands. Like in the case of neural networks, they're fantastic at doing a whole bunch of things, but once you've trained a neural network to do something, it's a black box. You can't look inside.
What's a neural network? Sorry.
A neural network is...
I've heard of that term several times, and most of the times I just nod and say, yeah, of course.
Okay, it's like a computerized model of a brain of an animal.
Okay.
Ideally heading towards the way a human brain is structured.
Okay. So you were saying it's a black box?
Yeah. So you can't look inside it and say directly what it's doing in the same way that you can with some normal piece of code.
Okay.
Which is dangerous. You know, there's actually a move by Amber Rudd, the Home Secretary in the UK, she was testing out the idea of building what you might call a censorship machine that social media publishing companies would have to run on all of the data that their users submitted to them before displaying it publicly. Now, it's pretty clear that that was built with a kind of machine learning system. The danger is, and they were looking for terrorist material, was the idea, right? Okay. But the danger is when you feed it that information, it doesn't understand the concept of terrorists, and we can actually go on about, like, one man's terrorist is another man's freedom fighter, right?
Okay, yeah.
Yeah, in the really global view of it.
It depends on the view. I mean, for terrorism, for some people might be, like you said, freedom fighting for another one. So, but this is a very weird point to go, because that will always go on depending on the view of the person in hand. I mean, what's terrorism for you might not be for me, even though we might come from the same culture in religion or whatever. And I'm not trying to say that terrorism only comes from religion, and I'm not saying that at all. I'm just saying that it will always depend on the person who's watching it happen.
Yes, is subjective to the perceiver, precisely. Yeah. But, if we make a machine that's supposed to go out there and pick up terrorist material.
But sorry to interrupt. So, but the thing is, it's subjective because there are a multitude of things that we cannot at all put into code, I assume, or the amount of things that might go into one judgment of things. It's impossible, I assume, to put it into code, even though you might have machine learning that writes itself.
Yeah. So what you end up doing is you train it on a data set. Okay. So I say, this is a bunch of terrorist material that we want to keep off the network, or Amber Rudd would say off the internet in general. Now try on this broader data set and see if it can classify on its own what is and is not terrorist material.
Oh, okay. Yeah, makes sense.
But the danger is there. Like,
if you feed it the wrong data set.
Exactly. Who knows what we're actually training it to censor? Yeah, I think she's not actually going to try and implement this system. I think she was attempting to scare the social media companies into taking a stronger stance against terrorist material on the networks in general. But it's a pretty concerning prospect, I think.
And going back to data permanence, so you already, just to understand, so basically you saw that information control leads to authoritarianism. I nailed it now.
Part of it. Yeah,
and so you assume that the direct opposite will lead to the direct opposite at the same time in the spectrum of the politics. So if you assume that information control can lead to authoritarianism, that information permanence and the fact that no one will be able to change it, and it's permanent, as you said, will lead to a better democratic view of the world, will lead to a better...
So I think the internet has largely done the job of ensuring free expression in societies so that people can converse with one another and those ideas can spread and we can come to better consensus about things. What we haven't yet done, and what the Arweave attempts to address, is free expression over time. That is, I can say something today, and you can't make me not have said it in the future, and I can communicate it to Alice or Bob or whoever wants to listen in the future.
Okay.
So Solzhenitsyn, the guy that wrote the book I was mentioning,
the Gulag Archipelago.
That's correct. He had to hide the book in various locations, in the houses of friends and buried underground, in order to make sure that he could get it to a point where it could be published, and then so that there were copies of it that couldn't be lost. But a few times it was very nearly lost. He had to commit a large portion of it to memory. The point that we're attempting to make is if you can store the data permanently at any one time, once it's on that system, it can't be removed. There's no point the authoritarian regime even trying to control it, because it's, in our case, globally distributed, cryptographically verified, and financially incentivized to have upkeep upon it.
Okay, but if you go now to the authoritarianism politic view, if we saw the news coming into the earlier this week, that, for example, Telegram, the main chat messaging platform where people talk within the cryptographic communities, that they're doing the huge ICO of 1.7 billion, I think.
It's like 2.1 or something. It's crazy.
And they just got notice from the Russian government that they have to be stopped.
Yeah.
You have authoritarianism there, stopping it from working in that country. So
this is interesting, right? So the idea is that we're not so naive as to think that these services wouldn't be blocked in truly authoritarian countries.
Mm-hmm.
We are hopeful, though, that the small amounts of information that leak out of those countries, which happens in North Korea, for example, will make its way onto the Arweave. And then later, when those countries are liberalized again, people will actually be able to go back and see what their history was.
Oh.
And that record can't be lost.
Like a never forget kind of thing.
Yeah, well, I mean, it is never forget by, default. That's the whole...
Yeah.
But we also think it can be helpful to stop the descent into authoritarianism. Because these things... I have a Marxist friend of mine, actually, who who said something once that really stuck with me, which was that 1917 was when revolution died. There have been some revolutions after that, but they were fairly small. Actually, the major ones were slow progressions of society towards
innovation, political innovation.
Political innovation is a very Orwellian sounding term, but yes. Yeah, so we think it can be helpful potentially in slowing that descent.
So it's not only to eventually fight off because you may not be able to fight it off, but just to make sure that you don't get to a specific point.
Yeah.
Interesting. Okay, and so you're building, is it on your own blockchain, the Blockweave, right? So you're building a platform for the people to create their own dApps, their digital or distributed applications, right?
Decentralized apps.
Decentralized apps. So, and what kind of use cases have you seen it or have you thought of to use in your platform? Just in case there are any developers or any person out there listening to this episode right now, what kind of application and use cases you see as possible within the Arweave?
Yeah, so the things we'd really like to see are along the lines of decentralized social media, particularly the ability for people to talk to one another without a centralized authority in the middle stopping them.
But if you do that, what's the difference between you, for example, and Mastodon?
There are various different ways of doing it, as we would say actually scales. So the data is stored directly on the system, and there's financial incentives for it to stay there. That's one part of it. And also it's really easy to build on our system. So we have a HTTP interface with a whole bunch of libraries for various different languages, JavaScript, PHP, Erlang even, Java, all sorts of languages you can write applications in. And it's a really simple put and get interface. So you can actually interface it with your existing applications pretty easily in general. So we think that's a pretty great way of writing decentralized applications.
How weird would it to be? And I'm just thinking about it now. So we know that, for example, Slack as a free service, after 10,000 messages, it starts to get paid, I think, or in terms of storage. But let's take one step back before I go into this question. So is it expensive for someone to store any kind of data? And I'm assuming any kind of data on a Slack, it's nearly almost a text message size. It's some bytes, not even kbytes, I think. Is it expensive to store it on the
Arweave?
Yes, in the Arweave.
Not really, no. And what's interesting about it is it's not very expensive because it essentially becomes part of the proof of work in the system. So it just offsets value that the miners would expend on guessing random numbers. The more data in the system, less hashing happens.
Okay, how does that work? So, for example, I know that the blockchain itself, you keep adding stuff into the chain, and everybody's mining for the same chain. Everybody's mining for the same block, rather. Everybody's mining for the same information, right?
Yep.
How does it work with the Arweave?
So in a Blockweave, instead of just linking in the last block in the system, we pick a randomly chosen previous block, and we link that one in as well. And we also make it so that miners only require the last block to mine the system in general. They're not required to store the whole thing. And in fact, they store the last block, all of them, and then all of the other blocks they store, they are rewarded for through the system we call proof of access. So I mentioned that we link in the randomly chosen previous block into the generation of the next block. That means that in order to mine that next block, you have to have that randomly chosen old block. And if you don't have it, then the most efficient way to mine is to just sit still doing nothing, right? So if you have a copy of 1% of the Arweave, then you can mine usefully, where mining is this random number guessing competition.
The hashing kind of thing.
Okay. Yeah, precisely. For 1% of the time. But if you store 100% of the weave, then you can mine or take part in the hashing competition 100% of the time.
So you're trying to make sure that the miners themselves get a specific percentage of the weave, so that there can be financial incentives to be a part of the Blockweave. Is that it?
Yeah, precisely.
But the amount of data that you're trying to get, if you're trying to get like an archive to the whole internet, I mean, the amount of data that you're talking about, I mean, if we're just talking about the data consumed or created per day. It's ridiculous, the amount of data. How can you guarantee that there's enough space?
Yeah, so this is interesting. For a start, we're not archiving the whole internet. It's hand curated. And users pay.
When you say hand curated, it's someone makes sure that specific thing is
precisely.
Okay.
Yeah, and users pay for what they store. But the pricing of data entry into the system is based on the availability of data storage in the system. So if there's low data storage availability, the price for adding data to the system is higher. Converse is true. And what's interesting about that is as the data storage fees increase, some people will stop storing data in the system, but other people will continue to store it. And that means that it's more profitable to mine. When it's more profitable to mine, more miners come to the system, the amount of data storage available increases, and the price decreases again.
So in terms of, okay, let's assume that I want to, is it possible, okay, I know that, for example, you have Filecoin and storage. At least storage, I know that's already up in terms of renting your own hard drive space. What's the difference between, let's say, first Filecoin and then storage?
So
okay, I know that they do it like a SaaS business. It's not permanent.
Yeah, I mean, the basic difference is that they're using networks for storage in the background rather than storing the data on-chain, as we would call it. So in the Arweave, the data you store is cryptographically, it's literally built into the Blockweave data structure itself.
So the Blockweave is the data that you store.
Precisely. Whereas, say, in Filecoin, you're essentially just doing payment settlement for data stored in IPFS in the background. But the critical difference from the point of view of the user is you pay once to store data in the Arweave, and there's financial incentives for other people to then maintain the data and serve it to you at the appropriate moment. Whereas in Filecoin, you pay for how long you store it.
Okay, then let's assume that I want to start mining for Arweave, and I buy like a huge ass server for 10 terabytes.
Sure.
And I want to be rich, and I'm start mining, and I'm mining the Euro token that we'll be talking a little bit further down the road here in the interview. So I buy 10 terabytes of storage, and after a month, I've been able to fill all that storage with just stuff from Arweave. But then another 10 terabytes are created. Is my server or is my node cryptographically choosing what are the best data to store, or am I supposed to go and curating the main storage that I'm getting? I don't know if
I think so. Basically, the network self-optimizes redundancy. So if there's 10 terabytes stored in the network and there's 100 terabytes of data storage available in the network, then broadly speaking, the financial incentives will cause the network to make 10 replications of all the data in the system. However, if there's 100 terabytes of storage available in the network, this is not a realistic case. But
for now or at all?
At all, because it wouldn't get to this level. But anyway, and there was 90 terabytes worth of data stored, then there would be roughly one replication of each piece of data. And the point there is that you are incentivized to store the data that very few other people are storing, right? Because if there's 100 people storing a piece of data, a recall block, we'll call it, and that block is chosen, and say you've all got equal hashing power for the sake of argument, then there's a 1 in 101 chance of you winning that block, right? And the reward associated with it. However, if there's another block that has 10 people storing it, then if you store that one, now you've got a 1 in 11 chance of winning the block reward, right? So you are incentivized to store the ones that other people.
But are you incentivized? So is it automatic that the Blockweave autocorrects itself, or am I, as the server owner or the storage owner, to
it's
go?
Automatic.
Okay.
Yeah.
Okay. So going now for a more broader vision of what you've been doing, what's the key learning that you've been having as the co-founder and CEO of the Arweave? The key learning, or the thing that you have been finding the most interesting about what you've been building?
I mean, the most exciting thing about the project for me, I think, is attempting to solve a small problem for society. You know, it's nice to put yourself to something you really, really care about. And what's amazing in this case is that it actually lines up, financially with doing well. So that's fantastic. It's really exciting. to have this opportunity to build something that is both politically is not the right word, I would even say, but it's just societary,
social impact,
socially, what I believe is the right thing to do, as well as
there's a financial.
Yeah.
Okay. So, and going once more on a broader vision. So you told us that you started looking a little bit more into blockchain in this area in 2010.
Yeah.
Assuming that there's someone finishing high school, going to college, working and trying to move into the blockchain area, where do you think they should start if they want to learn more about this specific topic?
I mean, what I instantly thought was ignore 90% of what you read, but that's very cynical. I think the thing is that focus on the tech.
So the technology, the code,
because in this space, the technology is the money. Like how the systems work, how they scale, is the money. There is no difference here. It's not like the birth of the internet, where there was this monetary side of it. Everyone was getting really excited, overly excited. And then there was the actual technology itself as something different. People were making businesses that were selling cars or whatever on the
internet. So focus on the technology. So what do you mean? So focus on the code, learn how to code, what languages. Let's assume it's someone who's straight out of college, never coded, or someone who's, okay, let's take out the college area now. Let's assume someone who's working a full-time job is very intrigued to what's happening here and might have some idea, might not know what blockchain is about, might not know how it works. What would be the first steps that you would tell them to take? Books, websites, whatever.
Wikipedia is your friend. Google is your friend. Even just read about what a blockchain is, but don't get taken with the financial side of it. Just read about what the technology does, because eventually that'll get you to the point where you understand what the constraints financially are. So one of the really obvious examples of this is that because of the way Bitcoin unfortunately doesn't scale very well, it has this 1 megabyte or 2 megabyte block limit, or 8 megabyte, depending on which fork you're looking at, block size limit. The Bitcoin transaction fees spiked to $30 at the end of 2017. And what's interesting about this is that this was a technical limitation of the code that anyone that looked at it and understood what was going on could tell you would happen ahead of time, ahead of the adoption, and it caused major problems.
Okay, can you go a little bit deeper in that, because I didn't understand that at all.
Sure.
Sorry.
So Bitcoin is limited to roughly 12 transactions per second.
Okay.
This is built into the code.
It's built into the code.
Yeah. Anyone could have told you this if they looked at what was actually happening under the hood. And anyone could also tell you if something is adopted, it gains mass adoption, which is what everyone was hoping would happen with Bitcoin, back in 2017. That is, you are going to run up against that limit, and there's no way around it. And then also, if you study the technology behind it, you understand that the miners are not incentivized to accept a kind of fork of the system where the block size is bigger, because it's actually less profitable for them slightly. Well, it's more difficult to mine, but whether that means that there'll be more transactions through the system and more usage is another argument. But critically, there's very little incentive for them to
accept larger nodes and larger blocks.
Or larger block sizes, yeah. So you could see that was going to happen ahead of time.
So getting that information beforehand for someone who's now, so basically learn the technology behind, go through the white papers, go through everything to understand the underlying technology, because then you will be able to understand if this technology is valid, if it reaches a certain point of scale.
Yeah, completely. And not just scaling in terms of what it actually allows you to do.
Okay, so is there any book that you'd now recommend someone to pick up, go to the store, go to Amazon and just buy it and understand more about that underlying technology?
I always think that actually, so Wikipedia has its flaws, right? That it's sort of essentially crowd curated knowledge, which obviously means some of it is not so helpful sometimes. But it's way more interactive than a book. A book is a kind of linear affair, typically. Right? You start it, and it's got a whole bunch of information that's useful to you and a whole bunch of information that's not useful to you. With Wikipedia or websites in general, You just click around it, and you get to focus on the bits that you don't understand, so you get up to speed quicker.
Outside of Wikipedia, is there any website that you follow more in terms of thought leadership?
So after you learn the basics, then I'd start reading the white papers. The Bitcoin white paper is for such an incredible leap forward in technology. The white paper is actually not as good as you might imagine, but it does tell you the basics that you need to understand the system.
Actually, Lasha, the previous interview and the previous guest, actually said that if you want to learn more about blockchain, you should understand the white paper for Bitcoin.
Yeah.
There are hundreds of white papers being launched every day, but if you understand at least the layer basis of technology but underlying the Bitcoin blockchain, you'll get some idea of at least how you should think. Is that it?
Yeah. And so in some ways, what's nice about the Bitcoin white paper is also what's not very good about it. So it's not very expansive.
It's 8 pages long, right?
It's 8 pages, yeah. And it finishes like midway down the 7th page or whatever. And it kind of just tails off, like they sort of ran out of steam. Very, very odd. But it's pretty condensed, right? There's not much fluff. So if you read it, you understand it, it takes like 2-3 hours, maybe max, depending on where you are with the technology. And you're in a reasonably good position, but it could be better written. That's for sure.
Okay, a few minutes ago, I asked you what were the key learnings that you've been having on the Arweave building side. What's been the hardest thing and the most difficult thing you've come across since beginning the project? And how did you overcome it as well?
I think the hardest thing is explaining how this system can build a new kind of permanent internet that is accessible in your web browser, just like normal. But the information stored on the system can't be removed or changed after the fact. It allows you to create permanent serverless applications. So if you're a blogger, you write your blog, you upload it to the system, it's there forever. The same with web applications. Trying to communicate that to people and the real vision for what that is, because if you say internet, actually we're just talking about the series of tubes. Right? It's not clear. So the answer, honestly, has been that we just avoid explaining it, and then.
Then how do you try to explain it to someone what you're doing, what you're building?
Well, we talk about how it's a global permanent hard drive, and I think later down the line, 3 or 4 years, we can start to express to people what the grand vision for this permanent internet is.
Very interesting. Okay, let's jump into a fire round.
Sure.
So this is how it works. I'll ask you one question. You'll have to tell me in 1 minute and explain it why, probably.
Okay.
Okay. What's the book you've given out the most?
Gulag Archipelago.
I assume that would be the one.
Oh, 1984 actually is the one
from George Orwell.
Yeah, that I have recommended to people most in my life. But the Gulag Archipelago, if you really...
So both very politically...
Yeah.
Okay. What's your favorite tool or tool you wouldn't be able to live without?
Erlang.
Erlang?
Yeah, it's a kind of concurrency-focused distributed programming language. It's really simple. The core constructs of the language... I mean, the syntax is terrible, but the core constructs of the language are so simple you can pick it up in a few days. And
if you already have some programming knowledge, I assume.
100%. Yeah, it's not your first programming language, unfortunately. Okay. But if you're reasonably adept at programming, there's nothing that I've found that you can't do well in Erlang.
But for example, imagine that I'm starting to program or already I'm a junior developer. Mm-hmm. Do you think it's better to learn Erlang or Solidity, for example?
Honestly, what I would recommend to junior programmers is that they learn as many languages as they can, because there's a point you get to where once you have learned enough that programming is no longer about the language you're using. The language you're using is just the tool to express the computation that you're designing. And one of the things I like most about Erlang is that it's just, at a basic level, it is just computation, and it's an easy expression of that. But I think you can only really get to that point if you've learned maybe 5 or 6 different programming languages. And the more you learn, the easier it is to just think in expressions
in programming terms.
it's not even programming. It's thinking in expressions of computation, which then you know roughly how the programming tool you're using works, and so you know how to express that computation in code. Yeah, exactly. In that syntax is really all it is.
Okay. Something you've changed. Tell me something you've changed your opinion in the last 6 months.
It's better to fail by your own errors than to fail by the incorrect advice of others.
Okay, can you repeat that?
Yeah, it's better to fail by your own errors of misjudgment than to fail by the misguided advice of others. Which is not to say that you shouldn't take advice of others. You definitely should. But you should take it and you should integrate it into your existing model of reality and then work out how to act. Rather than just being like, I think this guy knows more about me than this topic. I'll just take what he says. I think it's really important to...
How did you come across to that realization?
I mean, the Textiles program has been absolutely fantastic. One of the things it's done is expose us to 150 different pieces of advice a day. And yeah, that's been great. But I don't know. I think it's just taught me to stick to what I believe in and then maybe fail because I was wrong. That feeling is better than failing because somebody else gave you bad advice.
Interesting.
Which is not to say I got a lot of bad advice from Textiles. It's been fantastic. But yeah, you know.
Happy to hear that. Let's talk a little bit about, before going on to the last two questions, let's talk a little bit about your plans on the short and longer term for Arweave. So you're doing a token sale, a pre-token sale. Can you elaborate on that?
Yeah, sure. We're selling some of the tokens involved in the
Is it an ICO?
It's a private and community sale.
Okay, and in theory, that private and community sale will be enough to sustain the growth and the life or Arweave in terms of development on the longer term, or will you need to raise other rounds of token sales?
This raise should be enough for 3 to 5 years runway for the project. And maybe that's another thing I've learned over the last few months, is that token projects like ours, truly decentralized applications, really just don't fit the model of a normal startup or a company. It's not, so, you know, like it's enshrined in law in most countries that the role of a company is to create value for its shareholders. That's simply not what the Arweave project is about. So the plan, anyway, to go back to your point, is to sell some of the tokens now.
So if I'm an investor on you, my return on investment won't be dividends, will be on the value of the tokens that I buy. Okay, very well. One last question. If you started today from scratch, fully from the beginning, from scratch, where would you focus?
That's an interesting one. You know, I would largely do what we've done again.
So focus on computer science, computer programming, blockchain.
Oh, you mean like from scratch in my life? Or?
Yes.
Oh, interesting. I wouldn't have spent so much time doing my PhD. I would have done this earlier.
You would have started Arweave earlier. So the path would be pretty much the same.
Yeah, I would say so. But I deviated for 3 years building this decentralized operating system that's academically really interesting, but basically no one was ever going to use. And that actually I personally found very disappointing. And it wasn't a kind of lifestyle that I wanted to lead. As soon as I found something I was truly passionate about, and I was reading this book, and I realized that there was a piece of technology that I could build that could make a small dent in this enormous problem. My life had meaning, directly, clearly. And it sustained us through, a huge amount of like stress and difficulty. And every morning I still get up and I'm excited to do it. So like,
fantastic. That's the dream, right?
You just got to find something that you love.
Okay.
Do it.
That seems like a good segue to the next ask is, what's the best advice you'd be able right now to give to our listeners?
The pathways that you could take in life are extremely broader than you could imagine. Don't spend your life doing things that you hate. Find a way to do the things that you love. There are a lot of positions in life that are very, very restrained, financially restrained, or in other ways. But when you, it's hard to say. It's hard to put into words properly. But when you take personal responsibility for putting your life on a direction that you like, even if you can't achieve what it is you want to achieve now, today, tomorrow, or in 10 years even, it feels better, like way better.
Well, thank you very much for taking the time to talk with me and our listeners.
No problem, it's been fun.
Thank you so much for plugging into this conversation. Sam is truly someone who is building something with a much larger purpose, and he's very inspiring. It's a great honor to have you listen to this new podcast, and hope that if you have any question or anything that I can help you with, you feel free to reach out on social media. Once again, it's @itsDeandre or @Pioneers Show, or on the website pioneersshow.com. Any information that you might have missed will probably be linked up in the show notes. If you enjoyed this conversation, consider subscribing to make sure that this podcast grows and help everyone be the pioneers of their own lives and careers. If you enjoyed this conversation, please let me know. Once again, it was really a great pleasure having you over there. Have a great time. Talk to you later. Bye-bye.